So today we're going to look at continuity and look at graphs with different types of continuity. Well, we have never talked about continuity before, but we are about to learn something kind of new. So what is continuity? It's basically how the graph is continuous. So a graph is continuous if there are no breaks or holes. Okay, if there is a break, or hole, it is considered to be discontinuous. Okay, so let's look at these types of discontinuity. So if there is a break in the graph, it's considered discontinuous. So let's look at this one. This one is a straight line. Okay. It is a straight line, and I have a break at f of a here. I have a break at f of a, but f of a is defined up there. I continue to go in both directions, so this is considered to be removable discontinuity. Okay? So removable is when f of x is continuous everywhere except f at the hole x equals a. Okay. Jump discontinuity, if you see this, we continue. Oh, we're about to jump. And we're going to continue on the graph. So this one is a jump in the graph. This one is removable because I'm not jumping anywhere because I continue to go along this way. So jump is when f of x jumps from one point to one point. Okay. Infinite discontinuity is where it increases and decreases infinitely as x approaches some straight line, x equals a. Increases or decreases infinitely. So see, it's infinitely decreasing here, or we're infinitely increasing, and we're infinitely decreasing here. Okay, so it's going an infinitely increasing. See how it's going in two different directions there? Okay, so let's look at these examples and determine if they are continuous or if they are discontinuous. And if they're discontinuous, label them. So I want you to try to do these for me. Continuous just means there is no break or hole in the graph. Okay, so let's look at number 1 here. So, is this, oh, there's a hole there and I'm going to continue. So this is a removable discontinuity. Okay, at x equals, that is a negative 1, 2, 3. Okay, let's look here. So here we are increasing at a value and we're decreasing at that same x value. So if I were to draw a line down the middle here, this would be a infinite, good job, discontinuity. Infinite at x equals 1. Okay. All right. This one is also an infinite discontinuity. At x equals 2. But also what happens here, I have a jump in the graph right there. So that is a removable. I'm sorry, I didn't have a jump, but I have a break in the graph. How about that? Removable discontinuity at x equals 1, 2, 3, 4. Okay. Number 4 down there is no break in my graph, so this one is just going to be continuous. And then number 5, here I have, I'm coming to one point from the left side, then I'm going to jump and have another graph all the way. So this is called jump, discontinuity. At x equals 1, 2, 3, 4, 5 at negative 5. Okay. All right. Okay, and we've talked about end behavior already. We talked about that in Algebra 2. Sorry. Zoomed in a little bit, so a little bit off here. Okay, so end behavior is as x moves to infinity. What does f of x approach? As x approaches negative infinity, what does f of x approach? So that is called the end behavior. So your f of x is how you can define the end behavior. So let's look here. So as x approaches negative infinity here, f of x is increasing here. So it's approaching positive infinity. As x approaches positive infinity, so as x gets bigger and bigger, f of x is also going to be getting bigger and bigger. So the end behavior is positive in both directions. Okay, let's look here. So as x approaches infinity, okay, as x, I always like to do the negative first. As approaches negative infinity, f of x is also going to be approaching negative infinity. As x approaches positive infinity, f of x is going to be approaching, it's going up, so it's going to be going in the positive infinity direction. Okay, here as x approaches negative, so remember this is your negative direction, then here's my graph, it's continuing to go in the negative f direction. So f of x is going in the negative infinity direction. As x approaches positive infinity, here's my positive, I'm still going in the same direction. So f of x is also approaching negative infinity. Okay, so if you look at this one, these end behaviors are going in the opposite direction here, and these are going in the same direction here. Same direction, same direction. Okay. All right, graphs approaching certain values. So some graphs are going to be approaching, so as x moves toward positive infinity and negative infinity, it is possible for f of x to be approaching a certain value. Okay, so let's look here. So as x approaches negative infinity here, so as x approaches negative infinity, I am going still in the positive f of x direction. So this one does not have, so f of x is going to go in the positive f of x direction. As x approaches positive infinity, f of x is getting closer and closer to 1, 2, 3, 4, 5, to negative 5. So f of x is approaching negative 5. So this one is called, it's approaching a certain value. Okay? All right, let's look here. As x approaches infinity. So here's my negative infinity, here's my positive infinity. So x approaches positive infinity. Well, let's do negative, I'm sorry, because I want to stay consistent here. F of x is going to approach what y value here? 0. As x approaches positive infinity, f of x is also going to approach 0. All right, let's look here. So as x approaches negative infinity, so here's my negative infinity, what is f of x doing here? So as x gets smaller, what is happening to f of x? And it is approaching 2. As x approaches positive infinity, f of x is also going to be approaching 2. So basically you could draw a line through your graph there. Here, I could draw a line through my graph and it never touches it. It gets close and close to that value, but it never touches it. Okay? So I want you to go ahead and start working on your homework because this kind of takes a little bit of thinking through, so maybe y'all could help each other through it. and we'll finish tomorrow. So if you have any questions about anything, let me know.